Okay, all right. Okay, welcome back to the next lesson. Now we proceed to queuing theory, but this one is part two. Now we are going to start doing the dirty work. All right. Okay. So let's see what we have here. Okay. In this part, I'm going to look at MM1 model. Okay. As if you forgot about what is MM1 model, it is a candle notation. You can refer back to the queuing theory part one in the previous PowerPoint lesson. All right. So let's start. Okay. What is this MM1? Okay. You have to remember one is for your single channel model. Okay. M is for your Markovian process. Okay. In this case, it's a Poisson arrival and also exponential service time. More importantly, exponential service time is more or less in the negative exponential distribution. Okay, you can sense it, right? Because you have a service and then you imagine the refer back to your previous video where your always imagine your figurative illustration. Okay, you have the negative exponential curve over there, right? And then you have the expected curve at the upper part, and then you have the waiting time curve, which is on the opposite direction. Okay, so again, I cannot emphasize more. It is better for you to look at the book by Render and all, Quantitative Analysis for Management. Okay, it explained a little bit more extensively if you want to know more about this. Okay, welcome back to our MM1 scenario now. Okay, the first things first. Okay, if you have a single channel model, you have to follow these seven assumptions. If let's say this seven assumption is okay, only then you can go move forward to your characteristic or more important valuation that you need to do afterwards. Okay, so what are these assumptions? Okay, the first things, it should be a FIFO basis, meaning that if let's say you are an audience, if let's say you are a customer, you enter the system and then you must be the first to be served. Okay, if you enter earlier than than your second next customer. Okay, so you are the first come in and then you are the first to enter out of the system. Okay, that is the basic fundamental characteristic for your MM1 scenario. Okay, you may ask, okay, whatever happened if I have another basic? Okay, if I didn't follow this FIFO basis, okay, that one is another story, right? That one you need to follow through another different model, not this particular model. Remember, MM1 is one of the basic queuing theory model there. Okay, and then the second assumption, your arrival should be independent. Okay, but your arrival rate is constant. Okay, this is interesting. Based from this assumption, that's why your arrival now follows a Poisson distribution. Okay, if you notice, I put on my right hand side another definition of a Poisson process in case you forget about it. But I would recommend you revisit your statistical information a little bit further so that you can make sense of this, all right? That's the second and the third assumption is quite similar among with each other. Okay, the fourth assumption is, as I mentioned earlier, idealistic ways, but unfortunately, it may not be realistic. But we should make do with what we have, isn't it? Okay, so your assumptions should be there's no balking or reneging. Okay, if a customer enter the line, meaning that it must stay as it is, patiently stay as it is. All right, okay, and then now we proceed the assumption to the service time. Okay, similarly with the arrival time, you notice that your service time is also a variable, also independent, but also your average must be known. Okay, and then okay, why if you notice we are so caught up with the average must be known? Okay, because if we don't have the number for your average in the system, whether it's in arrival and also on the service time, we cannot proceed much more. Okay, because that is the fundamental value for your MM1 model. Okay, I'm going to tell you why that is so. Okay, there are lots of calculations. The basic calculation must include these two different entities. But if you have these two different entities, all your characteristic and operational calculation easy, easy peasy. Okay, especially if you are using software, for example, very easy. Okay, and then what else? Okay, your service time follow Markovian as well, negative exponential distribution. Okay. So that's about it. And then we see what happened then. Okay, this is the one that I said earlier. Okay, if let's say you already make sure that all these assumptions is being met, then now you are able to construct your operating characteristic. Okay, your operating characteristic is what? It is actually coming from these two entity that I mentioned earlier. Okay, your characteristic entity is your lambda, the representing of your mean number of arrival per time period. Okay, arrival, right? Lambda is your arrival, and your mu. Your mu is number of customer or units served per time period. All right, it's different, right? The first one is arrival, and the second one is the customer or unit served per time period. Okay, the arrival rate and the service rate must define for the same time period. Okay, what does it mean by these two rate must be defined for the same time period? Okay, meaning that like this: if let's say you have the average of your arrival time is in an hour, count your average number of arrival in hour, but for your mu you count it in let's say minutes. That does not make sense, right? Okay, so if let's say you have these two different measurement metrics, okay, for these two particular valuation, what you need to do, you need to transform one of them and follow another one, meaning that if you are talking about hour, those two entity you put that in an hour form. If let's say you are so really like the minutes, in a sense, you want to really scrutinize your valuation in a second. Okay, so you have to transform your hour into a second. Whatever it is, you have to make sure your matrix is the same. Okay, why? Because I've been doing it wrong, for example, okay, and I pay the cost, okay, right? For example, when I do the calculation it seems so far off, and I don't understand why that happens, because by right my calculation should be correct. By the end of the day, after long days, okay, I noticed that I actually put it wrong. Okay, the metric is wrong. Okay, so that's why the valuation does not make sense. The final answer does not make sense. All right, so that is something that you really need to be very aware of. In whatever things you do, actually, especially in mathematical formulation. All right. Okay. Now this is your characteristic. Okay. Remember, I said that what you only need is these two entity, lambda and also mu. Okay, I told you what happened here. You have all the seven entities. Okay, operating characteristic or whatever. Okay, meaning that for example, like number one, you have L, and then you have W, LQ, and so on. But the basic fundamental thing, it comes from your mu and also your lambda. Okay, for example, if you want to calculate your average number of customer or unit in the system, you actually have this value. Okay, what you have is just lambda and your mu. See, and then you just calculate as normal. The same thing happens for your average time. What you have is mu and lambda. What you have is lambda, mu, and lambda. Okay, everything. The same thing happens also for your WQ and also row over here. Okay, these are all the numbers and these are all the valuation that you need to keep in mind when you are talking about queuing theory. Okay, so you can scrutinize everything as is. Okay, especially if you look at Subscript. For example, like here, if you notice on my number 4 item, I have WQ there, right? But on my previous number 2 item, I don't have Q. What's the difference between these? Okay, the difference is just that on W stands for wait. Okay, so it's something like the waiting time for the customer to spend in. Okay, so this is the average time a customer spend in a system. In a system meaning that you come in line and then people service you and then you go out of the system. Whereas when you have WQ, meaning that your time now, your average time a customer spend waiting now is in the queue only. Okay, that's the difference between Q and also no Q. The same thing happens for your L. Okay, L and also LQ, right? So your row is the probability the service facility is being used at one particular time. Okay, so your 6 and 7 is just the probability. Okay, P naught is your ideal time, whereas your Pn greater than K means that the probability that the number of customer in the system is greater than K. K is whatever defined numbers that you have, all right? Okay, so by right, you know, okay, for example, whatever happen if, let's say, in a system, I have a customer 1, 2, 3, 4, and so on. Okay, we can calculate that based on the operating characteristic here. Mm. Okay, so that's the basic fundamental thing that you need to consider when you talk about a queuing theory of M1. Okay, so now how to actually put this in practice? All right, so how to put this in practice? Okay, this one I take from the text books by Render as well. Okay, this one is easy for you to understand. Okay, if let's say you have a mechanic, all right, this guy, he's a mechanic, okay, and he has one worker works for him. All right, Larry Arnold, meaning that the shop owner, okay, the mechanic names is read blank. That's not important, but whatever. Okay, so this guy read blank. Okay, he is able to install new muffler. Okay, I put muffler over here just in case you don't like a car. Okay, so the way read blank can install the new muffler, average rate is 3 hour. Okay, meaning that one every 20 minutes. Okay, as I mentioned earlier, if you want to move forward into an hour, just tick as 3. If you want to move forward into a minute, just stick to minutes. Okay, but in this case, we just focus on hour, meaning that, okay, so since he is able to install muffler 1 in every 20 minutes, so by right, 60 minutes without noticing, for example, break and so on. Okay, on average, it has about 3 units of mufflers per hour. Okay, so the customer needing this service arrive at the shop on the average of 2 per hour. Okay, always remember the meaning that uh, on average per hour we have 2 customers. Okay, they are not talking about every hour we have one, every hour we have two. No, it's some average, meaning that that is the meaning of the arrival time follows the Poisson distribution. That is what it means by that. Okay, it is random. That is why this queuing theory falls under probabilistic modeling. We don't know when it has the customer arrive, but on average, we are able to estimate that there will be 2 customers arrive in the shop every hour. So every other hours, on average two, but not on that particular exact minute. Okay, that one you need to remember. Okay, since we know that Larry Arnold only have one mechanic, read blank, so meaning that we only have one channel. Okay, so it is a single channel model. All right. So how actually we are able, okay, to calculate all the operating characteristic? It's like this. Okay, that's why I said you only need to have two correct. You only have two items over here, your lambda and also your mu, and then voila, you can get all the information. Why I said that? Once you have lambda two, mu three, you can get your L, you can get your W. Okay, okay, do the calculation and so on. You can get your LQ, you can get your WQ. Okay, if you get if you get lost a little bit how we get the value, always remember back the formulation for the rest of your characteristic over here. Okay, so that is how you calculate that. Okay, you substitute all the lambda and mu inside your formulation. Okay, and finally you have p naught equals to 0.33. Mind you, I didn't do anything, right? I just put the value inside and then I calculate as it is. Normal calculation, and these are all the values that we have. See, these are all the values. This one is your seven item. Your seven item. If you notice, your seven item comes right after your P naught. Okay, meaning that you want to find Pn greater than K. Okay, what are the Ks? Okay, Ks are all these valuation over here. Okay, all these items. Okay, the probability of more than K cars in the system, meaning that the probability of zero cars, okay, the probability is more than zero car. This one, the probability of more than one car, the probability of more than two cars, and so on. Okay, so only the first one, you can see over here. We start with zero over here because as you can see, um, you have straight away, right? If you substitute zero over here, k0, meaning that you only have 2 over 3, right? 2 over 3 is just 0.667. But actually, if you notice, you can see over here, note that this equal to 1 minus p naught. Okay, equals to 1 over 0.33, which just equal to 0.667, in case you want to make sense of it, meaning that um, the probability of more than zero cars, okay, and then the probability of more than zero cars must be zero is the stepping point, right? Zero cars is the one that you already calculate previously over here, okay, 0.33. So by right, the complementing scenario, it shouldn't have zero anymore. It must be greater than zero. It should become the complement behavior. So you know the probability is just 1 minus something. So 1 minus p naught is just this. That's why you get it. And you can actually get it from the um, formulation that already being established. Okay, so that's why I said queuing theory is quite straightforward valuation. Okay, now earlier we do it by hand manually, manual labor. Okay, so now what happened if let's say we try to solve it using a software, okay, automatically. Okay, so you're already familiar with qm for windows, and also I always need to remind you, qm for windows is not just one particular software that you need to you can use. You can always redevelop this formulation because you already know the formulation earlier, right? So you just transform your formulation into formulation in automation, and then you can solve it. So basically, if you can derive it again only once in Excel, also can. If you want to be more adventurous, you want to transform it into MATLAB, also can. Doesn't matter. Okay, it's just that since we are doing QM4 window earlier, so I would just simply put it using the QM4 window, as this one is already established prior, and you can just simply put the value inside your already established pre-installed information here. Okay, so in this case, your QM4 window, what you need to put inside is just this, and just this, and just this. Your arrival rate, your lambda 2, your mu3, and your number of server, you only have one mechanic, one. And then once you click solve over here, voila. Okay, without doing anything more, it's like a wizard, right? Okay, it's automatically being given to you. These are all the information that you get exactly as the valuation that you do by hand previously. Interesting, isn't it? Okay, so now we settle with that particular small fundamental valuation there. Okay, next. Okay, the most interesting discussion that we need to consider now is then what? Okay, we already have the valuation this. Then what? Okay, what is it? What is so important about knowing this? How many people are in the line? How much time do they need to wait? What then? Okay, so now by answering this question, you need to go back to your queuing theory part one earlier video, right? So meaning that what we need to know is we need to find the best possible cost that we are able to provide, isn't it? Okay, we want people to be satisfied with our service, but at the same time we don't have that much cost to give them. Okay, so how to find the trade-off between these two variables? Okay, so now in this case we are starting to look at the, oh sorry, this one is just another information. Okay, now we are starting to look at this cost. Okay, how can we calculate the cost? Okay. So always remember your cost is coming from two different channels. The first one is your service. The second one is from your waiting. Interesting, isn't it? Okay, so remember service and also waiting. Now we proceed with service first. Okay, this is the valuation for your service cost. You have a channel, you have the cost per channel. Okay, so your channel and your cost per channel. Okay, how to calculate the cost per channel? Okay, your channel you know already just one, right? Because you only have one mechanic. What about the cost for channel? Okay, and then we proceed again. That one is earlier. And then now we proceed to the waiting time. Okay, waiting time. What are the costs for the waiting time? Okay, so we have the total time spent waiting by our arrival, and then we have the cost of waiting per arrival. Okay, so doing all some calculation, this is your final total waiting cost. Okay, let's reflect a little bit. All right. My question earlier. Okay, the first one is your service time. Oh, sorry, service cost. Okay, how to calculate service cost? We know this is the calculation, but how can we get the valuation for the service cost? And then at the same time, how can we evaluate the waiting cost for the waiting cost? Okay, so if you a little bit lost, okay, you need to go back to video one. Okay, remember back about your problem with the river docking system. All right, so looking back at that, and then now you can come back here and then re-emphasize on what you have in hand. Okay, okay, I hope you do that. Okay, so now we can proceed over here. Okay, I put over here just in case you want to come back here and look at this. Okay, so these are actually your valuation. You have total waiting cost and you have total service cost over here. So how to move about? We know that total cost is just the comprise of two different costs put together. Okay, and then how to calculate the cost. Okay, so now we see how to calculate the waiting time first. Okay, so we now estimate. Okay, this is the concept of estimate. Okay, the $100 question. Okay, how to estimate actually the cost of customer waiting time? That's a very interesting question. Okay, so there are lots of different ways. Okay, for example, but normally in Arnold issues, it depends on experience. Okay, it depends on experience. You know your own business. You are able to estimate a little bit. That's why you have this estimation concept over here. All right. You have to be very, what we call that. You have to be very honest on doing the valuation. And if let's say you are not able to do that, you can always ask other people how their experience doing it. Okay, and you can tie them again back to your original experience. Difficult. There's no easy answer for getting the right estimates there. Okay, estimate itself is another branch of a problem. Okay, but to make things easy, for example, let's say your estimate cost of customers waiting time in line is 50 ringgit, $50 per hour. Okay, so once you have that estimation, now you can calculate, assuming your working hour is 8 hours per day. Okay, and assuming your lambda earlier is 2, okay, per hour. All right, and then your WQ, okay, come back, refer back to your original valuation, is 2 over 3. And then this is your cost per hour earlier. Okay, you have 50 ringgit per hour cost for your waiting time. Once you identify the valuation, then you calculate, this is what you get, 533.33. That one is one, the waiting time cost. Okay. And then how can you calculate the service cost? Service cost is easier. All right. Why I said service cost is easier? Because you are able, you know the mechanic wage or salary. Okay, that one is clear. You don't have to estimate at all. Okay. So if let's say your mechanic salary is 15 ringgit per hour, okay, so you put that into active 8 hour per day working hours, okay, and then your M just one channel, which means your mechanic is only one. I forgot the name. Blank, I think. Okay, and your CS is just your wage. Okay, your salary. So basically, this is your cost for your service. By the end of the day, your total cost is this. This is your waiting cost and this is your service cost. By right, these are the total cost for your valuation. See, the idea of finding the operating characteristic from your previous slides, okay, is actually just for you to get the information that you need. For example, your WQ, okay, and get that put inside your valuation for your costing. Then only you get the total cost of the system. Interesting, isn't it? Okay, I hope you can digest a little bit on this problem. Okay, once you already digest this problem, okay, the cost. Now, what happen if we play around with the current situation that we have? Okay, earlier we have Mr. Blank as our mechanic, right? He is able to do like what, three cars, three muffler, install three mufflers per hour. Okay, now let's say whatever happen if we are able to find another mechanic, okay, the newcomers, okay, more experienced worker, more experienced mechanic. Now instead of being like Blank, who is able to install the muffler, three mufflers per hour, now he is able to install four mufflers per hour. Four car service per hour. Okay, four mufflers per hour. Okay, you look at this one. It's just like the one step from 3 to 4. Okay, but you always have to remember. You may feel like, oh, so what's so much different about being like what, 3 to 4? Only one difference, isn't it? Okay, but that one we are talking about per hour. And then we are talking about business cycle. All right, so if let's say you have 8 hours per day, how significant increase it might be. Okay, and then we are talking about per day. What about per month? And what about per year or even 5 years? Okay, I think that is something worth pondering. Okay, meaning that you cannot just simply do a status quo kind of business orientation. If let's say you already satisfied with one worker and then that's it for the rest of your business cycle, and then okay, bye bye, that's it. You cannot do that, right? If you want to progress, you need to always make sure how to improve, how to improvise, how to make sure that you are actually in a making, not a loss making. You are making a profit. Okay, so that's why we keep on trying to change things. Okay, so let's say we lay off this Mr. Blank and we change into this particular guy. All right, who are able to install 4 cars per hour. Okay, now you can see over here. Okay, you do the same thing over again. You have L, W, LQ, WQ, row, and also pin dot, and finally you have PN. And then you can see over here, this valuation is completely different right now. Okay, and then what's more interesting is the calculation for your cost. Okay, the calculation for your cost. Okay, so remember earlier I put over here in case you forgot what is our initial total cost for one particular mechanic. Okay, this one is one mechanic with 15 wage is 15 ringgit, right? $15 per hour. Okay, so now this guy who are able to install 4 muffler per hour. Okay, so what happened now, your total daily waiting cost right now is changing. Okay, why it is changing? Because your lambda now is changing. All right, and then your WQ now is also changing. Okay, because your because your WQ now depending on your lambda as well. Okay, and then even though the waiting cost is the same, 50 per hour, but then your valuation now is different. All right, but then you need to also remember, when we talk, even though the waiting cost now is decreasing, okay, but when we talk about daily service cost, it's increasing, right? It's increasing. Why? Because right now your wage, your salary is more expensive than your previous Mr. Blank. Okay, Mr. Blank salary is just $15 per hour. Okay, but this guy, this very productive guy, is in $20 per hour. Okay, so this is the valuation for your total daily service cost, and then your total cost in your system right now. You need to addition both two. You sum up both the total daily cost, waiting cost, and also service cost. This is what you get. Hmm. Interesting, isn't it? By laying off Mr. Blank, okay, by laying off Mr. Blank and replace Mr. Blank with a more productive person, you are able to save your money. Actually, interesting, right? So you are able to save your money. This one is over here more or less like this. Like this, okay. So you can see over here. This is your initial value. This is your current value. You save 293 30 ringgit, 293 dollar 33 cent. Interesting, right? So you imagine the accumulation of your saving in a year, how much? Hmm. How much can you save? Okay, so you may seem that 1 3 to 4 is not uh does not change anything, and you may seem that, oh, okay, if you are doing a business, or if let's say you are in a decision making position in whatever organization that you are in, you may think that it is okay to keep your status quo. But trust me, it does not work that way. Okay, it's the efficiency is not, whatever it is, you have to make sure that you need to try. Okay, if you are, especially you coming from a quantitative base people, okay, you have to make sure that whatever you do, you have to try to make your system more efficient, and you have to make sure that your productivity is at the top. It is okay to lay off people and get someone in a better position, okay, but there are also other ways, for example, like maybe you feel like, oh, this is like a one size fit all thing, meaning that if your worker does not perform, you lay them off. Okay, it is like inhuman, isn't it? Okay, but you always have to remember there are certain things, okay, for you to do instead of just laying off people. If let's say Mr. Blank are able to install the muffler three cars per hour, now if you spend a little bit, okay, for his productivity, okay, you give him training, you might be able to improve the efficiency and the productivity of Mr. Blank, but your end point, you want him to be able to get from three muffler into four muffler. Okay, instead of lay him off the job, you can give him training just for the sake of, this is what you want. That is also doable. You give some investment on your human capital without laying him off, but the same thing, you don't need to go and find another expert to join your company. You don't know whether your new addition to your company is a good one or a bad one. Okay, so that is another alternative for you to do, not just simply lay off everyone that comes your way. Okay, so this is one of the trade-off that you need to consider. But whatever it is, you have to make sure that whatever things that you do, try to be as productive as you can in your decision making. Okay, so so I stop until here for my part two. Okay, on part three, we are going to look a little bit different. Okay, what if? Okay, I give you a teaser. For example, what if instead of replacing Mr. Blank with a more dashing mechanic that is very productive, what if I put another channel? What if I um, ask another people to join me? Okay, entry level. Okay, not that expert, similar to Mr. Blank. But meaning that instead of I'm having one person, now I have two-person. Will my cost reduce, or will I have a better trade-off between my waiting time versus my service cost? Okay, so that is what we are going to look at in queuing theory part 3. So stay tuned for part 3. Okay, I'll see you guys in the next lesson. All the best, you guys.